some examples of the type of protection that we're providing. There are, of course, different angles. When we're talking through this, when we say fileless protection, we're just referring to the type of attacks that don't rely on a file or signature. So here are some examples, like different types of ransomware in general, the type of malware that's being leveraged. But these are just, different areas that we're focused on when it comes to protection. Any of those jump off the page? If not, we'll touch on everything, but wasn't sure if anything you wanted to speak to. Sam, or the Olympics malware? That's everyone.
WannaCry or Locky?
How'd that go? Jeez. Well, nice. Well done. That's half the battle, is getting everyone to listen. So nice job on that. It helps on such a large attack, and the tool in place doesn't actually block it. And we'll touch on WannaCry is a great example, so we can touch on that. But thank you for kind of teeing up what you'd like to see here. So when it comes to our company and just the whole transgression of antivirus, so you're thinking about a tool like AVG that you have in place. They rely on files and signature scanning, and now there are a lot more attacks that don't rely on that. They take different approaches. And so when we started building out this tool about 4.5 years ago, our co-founders, so you can see in there, Mike Duffy, Jack Danahy, they've been in security for a while now, 20+ years, and have had successful exits into the likes of IBM. So they've been in the space for a while, and this has really been their baby, where they want to make sure that, for one, we're addressing a difficult problem, and two, we're actually following through on what we're claiming. We're not just making false claims or anything like that. We actually, proof is in the pudding. So that's kind of what our team's been working on the past 4.5 years, acquiring patents for how we deliver this type of protection, and went to market just over a year ago, now being third-party validated to be a full antivirus replacement. So when you're thinking you want to replace AVG, that's what we're here to do. That's what we're here to help solve. And so what we've been doing with other organizations, for us, the neat thing is that we're not, a niche tool, a niche tool that's focused on any one area. If you're looking for more reliable protection that just works and is straightforward to manage, then it doesn't matter what type of industry you're in, what type of organization that you're in. And for us, the way that we kind of measure our success, I mentioned earlier, we want to partner with organizations. And for us, it's invaluable to get feedback from individuals like yourself. You're the boots on the ground. You see it day in and day out. You're the one running your own internal WannaCry test. You see this stuff. And so for us, getting feedback around what's good, what could be better, the fact that we're aligning with how we claim to be straightforward and easy to manage, all of that, any of that feedback is how we measure our success. Because if we're improving the tool, then hopefully we're improving the experience and protection for you guys. That's kind of how we measure things on our end. And so when we've built out the tool, the reason behind us building it out was because there is this problem around protection that still exists. So I mentioned that, I think in the last call I mentioned that about 3 or so years ago, there were some tools that came out that did a great job at shaking up the antivirus space, improving off tools like AVG. But unfortunately, we're still seeing these type of attacks happen. This isn't supposed to be scare you statistic slide. It's just supposed to show you that these fileless, put that in quotes, type of attacks are the most prevalent, and they're quite successful when they target companies, and companies end up getting infected by them. I mean, WannaCry being an example, you did a quick little test and saw that it wasn't blocked. I mean, that's just one example of many of these type of attacks. Oh, okay, gotcha. Okay, well, the point remains is that the WannaCry attack is one of many. Yeah, it wouldn't have been the same as doing internal education. Right. So, got it. Okay, well, the scare tactic worked. Got it. Okay, well, that type of situation, those type of attacks are why we built out our tool. Because, I mean, you're concerned about it to the extent that you did that little scare tactic internally, and other organizations are aware of these types of attacks and are continuing to improve upon their security posture. So it's encouraging. We're helping solve a problem that's happening now. And as I mentioned, a lot of these other tools that have started to do this, unfortunately, they haven't fully solved the problem. And when it comes to protection, they're still doing scanning of files and signatures, so they still have that component. They do have some more visibility now. Maybe they're down to like the operating system kernel level. But as they're doing this scanning still, what ends up happening is they're generating a lot of false positives because of the scanning that they're doing. Now, they do have add-on features that you can turn on to block certain fileless attack angles or vectors, like turn off your scripts and stuff like that. But what we found and what we're seeing is that with these type of features, it ends up being very much a light switch type of approach, on or off. And what ends up happening is if you turn up protection to be the best with these tools, it ends up generating the most false positives. And it ends up, for your end, because of how cumbersome that can be to manage, it ends up making it so that you guys have to determine, all right, what's an acceptable level of risk that we can have and still do our day-to-day and not be buried in having to reconfigure and whitelist and do all that jazz. So we did not agree with that. We thought that you as a company shouldn't have to determine that. And so that's kind of where we focused on the three areas of improving. So first and foremost, protection drives everything. So we're taking a unique approach to how we deliver the protection with a patented RapidVisor agent. I'll show you that in a sec. That's down at the CPU level. So getting even more visibility there. But on the performance side, we're leveraging responsive machine learning that's training nightly. So it's not every 6 months push out an update that you have to reconfigure. We're staying on top of this nightly just to make sure that we have the most intelligence on our end to derive this protection. And when you boil it all down, the experience is the most important for you guys, and making it straightforward and intuitive. So when you see the actual platform, just want to make sure that you don't glance past everything that's actually going into it on the back end, what's driving it, because we intentionally made it that easy to use as a tool. So when it comes to protection, this is kind of building off the introduction. Our philosophy, we don't really care, I guess, what the attack angle or vector is. Our goal is to block early and block often. So we build out redundancies to make sure that we have several at-bats, several opportunities to block these attacks. And the WannaCry example is perfect because, I may have mentioned this on the last call, a lot of tools will eventually block the executable further downstream. But the way that got to that point was through some exploits up front. So we first and foremost block the eternal blue exploit, then the process injection exploit, and then ultimately we block the executable too. But the idea being that we don't think that your environment's clean if they even got to that point, so we'd rather block it outright to start. So that's kind of where we focus on the protection side of the house and how we're able to deliver it. And this is what really sets us apart from any of the other tools and challenged it. You won't see this in any other demonstrations, tools, experience, etc. I mean, there's a reason that we have patents around how we deliver this. Now, has the RapidVisor slide, did that come up on your end yet? Okay, perfect. So with the RapidVisor slide, well, with this this picture here, do you see that blue shim there right above the CPU level? That's where we actually deploy the agent itself, with the idea being that as these calls are being made, we have separate, different opportunities to actually block it. And the whole point being that we don't want to conflict with any of your systems. And that's why the agent itself is so lightweight. We'll actually show you that it actually doesn't even show up in the system tray. We would prefer to have almost a set it and forget it type of approach, where the protection automatically blocks these attacks for you. Now, when it comes to your infrastructure, maybe this would be a good opportunity, Kevin, if you don't mind, to kind of chime in and speak a little bit to this. But as Kevin's about to pivot into kind of the technical side of how we deliver, do you have any questions on this? Just to start with what I've gone over so far.
Are you referring to things like Spectre and Meltdown, or more things like Eternal Blue? So Spectre and Meltdown are really interesting from an attack vector. It's something that after talking to many of our customer bases, it's not really a vulnerability worth investing the time into trying to detach. Although where we sit in the system would allow us to intercept calls that would be attempting to perform Spectre and Meltdown. To do so would obviously require a really serious amount of engineering and taking a step back to be able to run arbitrary code that would modify the CPU would require the ability to run that code in the first place, which means the system has to have been compromised in another manner. So rather than reinvesting time into an attack that we're really only seeing against cloud providers, as it makes the most sense to jump to neighboring containers utilizing Spectre, is to actually try and head these things off the path and not allow someone to get on the system in the first place. Does that make sense, Ryan? So yeah, I mean, we're constantly on the watch out, and it's not to say that we're not keeping our ear to the ground. I have yet to see a POC of someone actually use this successfully within an attack. That's why the cloud providers, they're the ones who are really concerned about this, because you can natively run code within your container, and you can access the same RAM pool as the neighboring container, because it's all in the same physical hardware. And that's where Spectre and Meltdown are really going to do their most damage against the client machine. It's not worth the amount of effort put in when you can do something effectively the same by just getting someone to open the wrong Word document, or get phished and go to the wrong email website. There's such easier ways to have the same net effect that we haven't built that technology. Not to say we can't, it just doesn't really make sense for customers if you're not a data center. Now for Eternal Blue, that's a whole other story, as that was with leveraged WannaCry from the initial Invector. That is something we actually block. Even though Eternal Blue was the exploit within SMB, it then dropped Double Pulsar, and Double Pulsar was a particular exploit against the Windows kernel as a means to do privilege escalation, to go from logged in user to NT authority. And what that was attempting to modify was the LSTAR MSR on the CPU itself, the model specific registry. And that is a call we did recognize. MSRs should never be modified post-boot. And by seeing that call attempt to come through our Parapaster hypervisor, which I'll touch on in a second, since that instruction was going to the CPU, we denied it. Without ever knowing what Eternal Blue was or what the exploit was, if we see MSRs that are attempting to be modified, we know they should never be modified, so we just drop those instructions. So while a machine, say, that had SMB open and someone ran the exploit against it, would return, yes, the machine is vulnerable. Yes, the exploit ran successfully. If the potential for the privilege escalation would be mitigated, it would never gain NT authority on the machine, thus not allowing WannaCry to actually be deployed locally. So that's much more on the exploitation and post-exploitation side, but that's really where the CPU monitoring comes in, as we have an opportunity to enforce integrity both in kernel space services like SNEP and SMAP, and CPU integrity when it comes to MSR modifications. Did that make sense, Ryan, or any questions on that? I know I sometimes get on a tangent. Perfect. So I've kind of already alluded to where we sit within the system. Barkley itself is a Windows service, so we would deploy it in the same way that you'd be deploying AVG today. Yet our level of visibility is drastically different. AVG is really a user space monitoring tool. It's something that's going to be doing your tangible scanning, as you know. It's just signatures. I'm sure they probably have some type of behavioral functionality that they offer. Most tools in the AV and next-gen AV tool state they do so, but you're really talking about hooking onto Windows APIs like detours to gain view-only or read-only, if you will, ability to natively intercept how processes are spawning within user space and how they're interacting with the kernel. That's a polling-based or asynchronous approach to this, and you lose out on how malware and ransomware have moved beyond tangible files as a main vector. It's no longer, virus.exe anymore. Now it's things being embedded into JPEGs through steganography. It's the abuse of Windows macros to PowerShell handoffs. It's drive-by downloads through iframes and browsers. It's batch scripts. It's DB scripts. Things that already are present on the system. So rather than write code that can be caught in so many ways because it's a unique indicator, think of DNS filtering or firewall restrictive for known bad domains to IPSs and IDSs. It's sort of all caught WannaCry. If we're using that as an example, if you use Word, there's nothing to scan for. A scanner will return a Word document saying it's Word, signed by Microsoft, but you can effectively rewrite a piece of ransomware using solely PowerShell commands, which becomes incredibly challenging to defend against because scripts are such an important part of how a business operates on the day-to-day. So where we went with this and what we designed is what's known as our RapidVisor, and what really powers this is our Parapass-through hypervisor, which hooks into the local motherboard utilizing the VTX extensions to do syscall redirection. Syscall obviously being the native way applications talk to the CPU, which gives us near real-time understanding of each of these particular calls. So rather than relying on how the file got there or what the attack is, we look for the intent, something that's downstream. Ransomware still needs to figure out what to ransom once it's deployed on the system. It needs to find all the PDFs and the docx's and the Excel files or what have you, and those are direct interactions with the operating system, which conversely turn into syscalls, which means we have the ability to understand that behavior without having to rely on higher level concepts like indicators of compromise, which already assume the attack is in play. You're catching that a file has been encrypted, a canary has been tripped, or that there's some kind of bad network traffic, which already denotes that arbitrary code has been run successfully on the system, and now you're there to clean it up. So by sitting ourselves and essentially acting as a proxy between the OS and the CPU, we have an opportunity to natively not just view syscalls, but control them. So that if we see something that's a part of a concert of actions, a Word document is written to disk, that Word document kicks off a macro, and that macro has VB script, and that VB script is actually just handing off PowerShell commands, which is by far the most effective malware we've seen in the last year or so, is using a scenario like that. All of those particular processes, the root process being WinWord, calling sub-processes like PowerShell.exe, all the particular commands that are being entered, all architecturally have to go through us now. So it's not about the fact that it was a Word document, and it's not about the fact that it's using a macro, it's legitimate features. not even the fact that it's using PowerShell, which is obviously a documented piece of function of the Windows operating system. It's about all those events happening in concert and what are they trying to do. It still has to find the files to overwrite, and it still has to try and overwrite them. And that is the action that Barkley will recognize, saying, all of a sudden, we're seeing something attempt to harm the system, and that's when we'll kick in, and we won't allow these calls to fully execute. They'll never reach the CPU, which terminates the offending process upon being recognized as attempting to do something malicious, which gives us the opportunity to do this at the earliest stage possible. There is no whitelist, there is no policy management engine, there's no configuration. We do everything we do behaviorally, and we do it in a way that is so incredibly performant as by hooking syscalls, we have no active scanner. We don't need to look for things. Everything has to come through us. So at idle, we're generally talking about 0.1% of the CPU being utilized. During a block, you might see a spike to 1%, 2% maybe, and then drop back down in a matter of seconds. And again, rather than rely on the file or what the file is doing, it's about the downstream behavior of anything. So we are essentially file agnostic, as we're starting to see malware move away from EXEs and do file formats that are not handled by other types of antivirus solutions, JPEGs in particular, or utilizing scripting engines that are already in place, as now everything is memory resident, thus necessitating something that can actually understand all of this in near real time, not in a polling or an asynchronous approach, which is really how most next-gen solutions work. The indicators are compromised. So Ryan, that's Barkley's agent from a 10,000-foot view. We support Windows 7 and above and Server 2008 R2 and above. We install the Windows service, and then each agent will hook in the way I just described and just start listening. And then everything will be understood in near real time, will terminate offending processes, will allow good ones through. And then upon any incident, we'll report that back up to our cloud console, which is what I'm going to walk you through during the demonstration purpose. But I want to take a pause here and ask if you have any questions on this. This is unlike any other product on the market. The ability for us to actually take data from user space, kernel space, and syscall hooking and do integrity enforcement, both for CPU calls, along with giving SMEP and SNAP a fighting chance if someone's trying to do ROP chain bypasses or stack pivots or other types of post-exploitation techniques, is a patented solution. No one else can do this, and no one else has developed this, which is why it took us 4.5 years to build it.
So Ryan, do you have plans to be looking at other tools as well as that April contract comes up? Okay, so it hasn't been like explicitly decided to not go with AVG. You just know that that's the window of opportunity if you're going to get a different tool. Got it. When you say convince them, like you're the one evaluating, looking at the tool. So say, and I want to understand what that process looks like, but I don't want to derail it all. You evaluate, and then who ultimately makes the decision whether you guys are able to go with the new tool? Is that the department head, the CIO? Got it. Okay, so not to oversimplify, but you find a tool that you like, you keep the department head in the mix, and Chris said, okay, that sounds pretty sweet. Yeah, let's move forward with that, but we got to check with the CIO, and the CIO is the one who says, all right, this does or doesn't fit in the budget.
Yeah.
Right.
Yeah. It's something we hear quite often. These are the titans of industry, if you will, when it comes to particular tools. And they're not bad at what they do. They're just focused on executable files, which is no longer the vector that we're seeing malware use because of how good they've gotten. And that's why you see them kind of work more holistic solutions. They become firewall managers and browser scanners and email filtering. They're adding on more modules, but the root problem is if you build something that's not executable, it's going to get around those tools. Yeah, right.
All right, so sorry, didn't mean to derail there. We want to understand that because if it's, helping you present to Chris to show the value of and then figuring out the fund financial budget side of the house, we want to support at whatever step. But let's stay on focus here. Make sure you see the actual demo.
Yeah, so I got one last slide for you, Ryan. I'm gonna jump right in because how we do this, how we power that agent to make sure we're not, false positing on an incredibly high rate because we're using behavioral learning. We don't have the context that you have of how your applications work. So when you install that agent, what it's doing is it's listening for bad stuff in the manner I described, but it's also listening for how your applications work. Think of their particular unique profiles of how they're interacting with the system. What type of calls are they making? What type of handoffs are they doing? And we can take those in as unique data points to train upon. So we use machine learning as a means to deconstruct executable files as they're loaded into RAM. And this gives us the opportunity to train nightly. We take in bad stuff all day, detonate it, understand how it works, and then using this model of generating data points on your particular software, we can build a software profile that we use as a trained against in our malware factory, what we call Evolve IQ. This is something we host in our backend that is seamless to your agents, and that they'll report in these data models, if you will, and give us the understanding of how to train against all the bad stuff. So that way, when your machine boots up in the morning, the first thing it will do is establish an outbound TLS connection to us, ask, do you have a new protection model for us? And we'll say, yes, we do. Here's all the net new malware over the last 24 hours that has then been trained against all of your software profiles. So that way we have the ability to provide the fewest false positives as we know how your behavior works and we know how the malware works. So if we see a cross correlation between the two, we can determine what is the same behavior a goodware or one of your applications is doing versus something that's mimicking the same behavior but is a net new piece of malware on the system or something acting maliciously. And that's what we call Evolve IQ. This is our second set of patents, if you will, being able to build a model based on how your organization works from a software perspective and then do this on a 24-hour update schedule so we can always be looking and collecting bad things and then training upon how your information works. And now that's not to say we're taking anything out of your environment. All of our collection's done client-side. All of our protection is done client-side. The only thing we're sending up is what you described more as, attributes. What's a Windows API call? Not full executable extraction. We're not scraping RAM. We're not doing any information extraction, just behaviorally how these applications work. Does that make sense, Ryan, or any questions on that? Cool. Let me just exit out of here and get right into the demonstration portion of it. So can you see this? My Windows 7 machine I have here. All right, perfect. So what I'm going to do really quickly is I'm just going to go ahead and detonate one particular piece of ransomware just so I have an alert to actually show you in the portal. I have Barkley installed on this machine, but it's in its monitor mode, so it'll actually allow me to run this, but it will log an event, if you will, CloudSign. This is something that is doing something very similar to the tactic I was describing before. The macro is, oh yeah, quite often. I am a trained professional and I live incredibly on the edge. So yeah, this is something I've actually modified to de-weaponize it. This is not the full variant. This came from Locky, but you can see that I've actually gone through and I've commented out some of the more viral aspects of it. It's just targeting one PDF versus my entire drive for efficiency's sake. But this is where it got really nasty. It would delete shadow copies. So if you're looking at other protection tools that rely on IOCs, so again, everything's really done post-compromise if you're not talking about native syscall interception, and only we can do that. So they rely on snapshots. You know, if your canary is overwritten, revert back. But if you've already overwritten the snapshots, the tool will recognize, yeah, there's ransomware happening, but I have nothing to revert back to anymore. And that made this so challenging to deal with at scale, as it upended how most next-gen AV tools work. So again, I've targeted one file just for efficiency's sake, but this is how it works, is it's all native PowerShell. And that is non-tangible. It's all memory resident. You can't scan for this stuff. So you need downstream effects, but you need to do it in a way where it's balanced between recognizing what is a good script and what is a bad script, so that you're not spending all day in a solution saying, well, you know, user X can use scripts now, and then when they update their file, which gets a new hash, you have to go build a new policy around that. That means you have, you know, your CIO yelling at you, damn, why can't I open my Excel document and run my particular field? So by Barkley being in line like that, there is no configuration. There's no features. There's no nothing you have to do. So by running that, you know, I targeted this particular PDF in my downloads folder. Now it's just junk data. As you can see, it all works. But if I go back to Barkley, and Barkley is hosted up in AWS by us, and each agent will call home. So when I log in, it'll take me to my status page, and you'll see that in my most recent instance here, I have some demo ones, and then I have one that kicked off 1 minute ago. This is my Windows 7 VM that I'm currently on. I'm currently logged in as the user Barkley, and I have an opportunity to click directly into that incident. And everything we do within Barkley is proactive. We've already blocked something. When we notify you, we've already done our job. There is no other configuration you have to do. There's no policies, there's no whitelisting. You just deploy the agent, and we'll start hooking in the way I've described and start baselining and then start terminating as we see fit. And we will report back an incident when the agent has blocked something, and that's all done near real time. As long as there's an ability to establish an outbound TLS connection, you'll see an incident like this. We'll show you what it is, why it is, and where we blocked it, from its type of Word document, where it lives on the system, to any particular command to pass off, along with some forensic information that you want to start looking left, right, from how big is the file, what was the parent process, and does it exist on other machines. Have multiple users attempted to interact with this file. Again, we're all at runtime, so it requires a user opening or double clicking, which as you can see, it's not that hard to trick a user into doing that, but we'll start to group them up and show you how many unique machines have had that block on it, along with the current user logged in at the date and time. So all of our incidents will report back here, but if the event that, say, your ISP drops your link and there is no connectivity, there is no feature loss within Barkley. We do not require an active internet connection to work. It's really about management and notifications. Anything that the agent can see from a harmful perspective, it will continually terminate, even if there's no active internet connection, and it will report back when that link is reestablished. So you can even take a device with Barkley out of the environment, as long as it can establish TLS at some point. So maybe you put them on laptops and users bring them home, connect to their home wireless network. That's totally fine. Our protection goes with them as it's on the device at all times, and as long as that's powered up, Barkley's there. So this gives you the opportunity to even extend your capabilities, but also interact with those devices as necessary in the event that maybe we do false positive. And that statistically, we've gotten really good at this, but there's always a chance any security software, especially ones that are behavioral based, to get it wrong at some point. So I just clicked into a random executable we had flagged. Let's say this was actually good and you knew that, you would go ahead and override that, which is an organizational-wide change that will kick off a near real-time update to every endpoint, saying the next time you double-click on this, alphanumeric string of executable file, allow it to run. We will not inhibit it. And this is actually going to inform our machine learning model, saying this is a unique data point of that you false positive on this file, train that attribute out. Whatever we thought was bad about this, figure out why it was bad, and then get rid of it from our data set. That way, we'll start training a unique model accounting for this particular behavior going forward, so that we won't attempt a false positive on it, even if there's neighboring software. Maybe it's part of a suite of tools. The behavior will be the same, or if it updates in the future, maybe the hash will change, but its behavior won't. So you won't have to say re-override it. And all of that override functionality can even be done directly from your phone. So when we shoot off an incident to you, you can receive an email notification, open that particular email on your phone, will give you a link to log back into the product, and then you have the opportunity to, like I'm doing here, I'm just rendering an iPhone directly within Chrome, but to show you that we're all web compatible, click directly into incidents and review them, along with override if necessary, as you see fit. Now, any questions on the incident review, Ron? Is this making sense?
Yeah, the GoToMeeting lags a little bit, but this part is pretty badass. We're getting some awesome feedback around when you're running around. If something pops up, just doing it on your phone and not having to go find a desk and sit down. Keeping you guys out of the tool. If we can do that and keep protection automated, that's our goal.
Yeah, this entire UI is designed to be almost passive, in that the onus or responsibility for providing updates, protection, incidents is really built into the product from an automation standpoint. When there is an update, we'll ship it down to all your endpoints. When your endpoints have an incident, they'll automatically report back to the Cloud Console. When there's an incident, it'll be then emailed to you if necessary. That way you can essentially walk away from this and only log in when you see necessary to do so via the emails we're sending to you, as we're constantly learning, we're constantly blocking, which means you don't have to sit here all day and look at this thing. And even deploying it, we've tried to make it as simple as possible. So each agent, say we deploy on all of your endpoints, and we give you one file to do so. We give you a customized executable package, whereupon if it's installed on any compatible Windows device, it will call home to your particular portal and create a unique record for that portal going forward. That way, each endpoint gets its own management view, if you will. So we give you this file, or you can extrapolate an MSI if you want to push this out via SCCM. We don't require the device to be restarted, and we can install quietly. So there's no impact to the user, even when installing Barkley. And then each device going forward will show up here on your endpoints tab, like I have here. Here's my Windows 7 device where I turned off protection to run that Word document. You can see that I did that right before our demonstration. Everything we do is near real time, so I can go and turn that back on. And each endpoint gets its own life cycle from, is it up to date? How long is it checking in? Who's in the device right now? Along with were there any incidents reported with it. Now, looking at the clock here, Ryan, I want to make sure I'm being respectful of your time, but this is essentially Barkley end-to-end. There is no other configuration you have to do other than deploying the software, and then we take over.
So Ryan, on the note of the clock here, Kevin and I do have to jump in, just under, well, about 2 minutes here. But what I would like to do is find a time tomorrow, the two of us kind of hatch a plan for moving forward, getting you more comfortable with it, whatever. But any questions on the tool itself and just what we've run through here while all three of us are together?
Mm-hmm. Yeah, I do my bad stuff in one place. Otherwise, I'll break my operational security. Mm-hmm. If there's something. Mm-hmm. Yeah. So if I just turn protection back on, and let's say I tried to rerun that same sample, as it was already effective, it terminated all processes, so there's nothing else to say do. But let's rerun it again. What I'm getting at is that there's something that's already memory resonant that we can identify from bad behavior. As soon as you install Barkley, we'll terminate the offending processes. Or if it runs again, like if I did this, we'll terminate the process. So it's recognizing the steps, the behavior, and effectively understanding it and then terminating it. And then we'll render a client-side pop-up letting you know that Barkley stopped something, and it'll report a secondary incident portal side. Yeah, and that pop-up is actually customizable to you. So you can put your logo in there, you can put your own header, you can put your own body. you imagine, what your pop-ups look like now, generic Trojan.1234, and putting in your own language and training your users how to respond effectively. Call this number, call you, email you at this particular email address, gives a much better shot of your users actually following the workflow when it's designed with at least a human element behind it, like actually putting in your own words that you're training them on.
So Ryan, I'm just looking at the clock here. How does, I think you said around lunch is better for you. Can we plan on catching up the two of us tomorrow, 1 o'clock your, or actually, no, sorry, noon your time, or actually either works for me. What's best for you tomorrow? Got it. I don't mean to... Okay. I don't mean to rush us off. I just see someone trying to get into this room. So I'll send you over an invite. You want me to just call you directly though?